talk about the design. Our learning objectives in the unit is to learn the difference between programming constructs, sequence selection, algorithm. We're going to learn how to use flowcharts and pseudocode when designing our algorithm. What is a top-down design and our structured diagrams, and how to use the structured diagram to describe our algorithm, and also learn the proper format used in pseudocode for our algorithm. First of all, we're going to introduce what is an algorithm. An algorithm is a series of steps to solve a problem or carry out a task. What is a flowchart? A flowchart is a common tool used to help plan and write down the steps needed for the flowchart. And this is an example of how do we draw a flowchart. Okay. We can see that the flowchart, we start from the beginning and we got a student score equals to 56. Next, this is a diamond shape, means decision making. If the score is greater than 10 and less than 50, then we put the student file into a certain grade. We give the score a certain grade, like grade D. And if it's not, we go to the next step, next process of deciding whether or not the score satisfies a condition. If the score is greater than 50 and less than 80, that means true, and then we go through this path, means the student grade is C, grade C. And if it's not, we go to the next step. If the score is greater than 80, then the student's grade is updated to grade B. And if it's not, it goes to grade U or grade E. Okay, so this is how a flowchart demonstrates to us how to convert a student's score into a grade. And these are the symbols that we should remember for making a flowcharts. We use this shape, this oval shape, to indicate the start or the end of an algorithm. And we use a rectangle to represent a process for performing a calculation. And input and output uses a parallelogram to when the data needs to be inputted or the outputted by the user. And decision making uses the diamond shape, which is to control the path taken through an algorithm based on the result of a condition. For a subroutine, we use two lines on top of a rectangle to call a predefined algorithm here as a subfunction. So these are the symbols that we should remember for the flowcharts and how the decision making impacts the path we take to the next step. The top-down design is a strategy for breaking down very complex tasks into more manageable subtasks, which in turn may be further subdivided. How to make a toast? This is the structure diagram that's demonstrating to us how to make a toast. First of all, we may think of the task as input, process, and output. So for input, we put the toast into the toaster as the input of our process. The next one is we are going to decide whether we should put butter or jam on top of the toaster, on top of the toast. If we finish and complete this task, we then move on to the next steps. Okay, so these are the examples of making a flowchart for toasts. So we have break down those very complex tasks into very small, manageable tasks, subtasks, for us to be able to make a toast in the end. Okay, so this is also an example of the flowcharts for calculating the average of a list. So if you could you could try and draw such a flowchart to iterate through each element of the list and calculate the total of the sum of the list elements, and then calculate the average of this list and output the average number in the end. Could you tell me, like, how much is the total of this list element summed together? Can you see from what is the requirements here? What's the total of the list? So this is the total of the list. 20, yes. And how much is the average? Yes, exactly. And how many items are in the list? Four items. However, when the item becomes 5, it goes out of the loop. So therefore, in order for the item to jump out of the loop, it has to be incremented to 5. Okay. So these are the 3 constructs that we have discussed in the programming concepts. First is sequence, the order in which lines of code are written, usually from top to bottom. And we can notice that the sequence of how the program is executed is right in the order of the sequence. The second one is the selection. They are the different paths which the user can use for determining through the inputs which paths they're going to take. And the iteration is also called a repetition. Is a program performs identical processes. The pseudocode for making this, to calculate the average of this, we can, there are no specific rules to write pseudocodes. The important thing is to be consistent. And pseudocode is a way of designing an algorithm using a syntax that looks similar to a real programming language. It is not combining in any programming language. However, it still has some certain syntax that we should pay attention to when we're writing the pseudocodes. Okay. So this is a demonstration of what are the total of the elements of this list and how much would item becomes when we finish the iteration. What's the list length, which is 4 elements. The average would be 5 and output would be 5. Another example for the user input a number and then the result equals number times counter and output the result. Can you tell me what is the purpose of this algorithm? The purpose of this algorithm is to input a number and use a counter which starts from 1 to times the number input with the counter and output the result. When the counter reaches 10, the iteration stops and it goes out of the loop. Okay, so repeat while the counter is less than or equal to 10. The structure diagram is where we focus on the main task that needs to be broken down further into several parts. Quite often we use the procedures like input, process, and output. For example, if we try to calculate the average, we need to first of all initialize our variables. So what are the variables that we're going to sum? And then second step would to calculate the average. And the third step would to output the average. And for calculate the average, we can break that down into calculate average and calculate total. Okay? So a subroutine, which means the programming language have libraries of subroutines that can be used in the program. We don't need to write those libraries again, but simply we can deploy such a library, for example, that's called random in Python, which contains subroutines to generate the random numbers, like x equals random dot random int 1 to 6. This will generate a random number between 1 and 6. And these are the exercises that we're going to write about. For example, the first question is to input a number. If the number is 1, 2, 3, output now it is spring now. If the number is between 4 to 6, we output it's summer now. If the number is between 7 to 9, we output it's autumn now. If the number is between 10 to 12, we output now it's winter. Okay? So this is how I write the pseudocode for these programs. Can you please write this first question so that you know how to write the pseudocode? And also the second question, this is to output a manual. Like the first choice is to print the manual. Second choice is to print the order for the customer. And if you input a 0, we exit the loop. So these are the two questions that we're going to ask the students to complete during the class. As a summary, we use 3 structures when writing the codes: sequence, selection, and iteration. Before coding, it is crucial to design an appropriate algorithm. A program refers to a value through variables. We use global or local variables. Our flowcharts are logic representation of a system, and our pseudocode describes the logic of a system without strict syntax requirements. Okay, so let's do the exercises now.